So today we are going to be starting our second day of our transformation procedure. So what we're going to do today is a plasmid prep. So we're going to take overnight cultures that were started from one of the colonies from our transformation plates, and we're going to isolate plasmid. So we have three samples. We have DH5 alpha, which is going to be our cells that were transformed with no plasmid. So we should not get plasmid from this prep. We have PSA 11, which is the plasmid that contains Glide A. And then we have PDH 223, which is the plasmid that contains Glide B. So what I'm going to do is take 1.5 mils from the flask and put it into one of these small microfuge tubes. You can see this tube is labeled for DH5 alpha. So what I'm going to do is use my micropipetter to transfer 1.5 mils into my microfuge tube. So I'm going to transfer 750 microliters 2 times into my microfuge tube. And that will give me my 1.5 mils. So I'm going to do this for each of my strains. So we have now aliquoted all of our samples into the microfuge tubes. So we are going to centrifuge our samples. This is the microcentrifuge. If you look at it, you'll notice that there are little holes where you can put your microfuge tubes. This particular microfuge will hold 24 samples. So what we're going to do is put our samples in here so that our tubes are going to be balanced. So I have 6 tubes total, so I'm going to put 3 tubes on one half of the side of the microcentrifuge, and then I'm going to put 3 tubes on the other side. This way, 1 is going to be across from 13, 2 will be across from 14, and 3 will be across from 15. There should be an equal number of empty spots on each side of our 2 banks of samples. So once you have your samples in here and your centrifuge is balanced, you're going to snap the lid on. You'll hear like an audible snap when it's snapped on. Then we can close the lid on our centrifuge, and then we can start our spin. So we're going to be spinning for 3 minutes. This is the time over here, and then we're going to be spinning at 12,000 RPM. So this is what that means. So that's 12,000. So our settings are good. So now we can hit the start button. So this is the start button. This is the stop button. And then this is the open lid button. So we're going to hit the start button. It's going to come up to speed. And we're now running at 12,000 RPM for 3 minutes. So our first spin is done. So we're going to open up our microcentrifuge. And when we pull our samples out, you'll notice that we now have a pellet. The pellet contains our cells, and then the clear liquid that you see on top is the supernatant. We are going to be removing the supernatant from all of our samples. So I'm just going to pull all of my samples out of the centrifuge. And now we're going to go remove the supernatant. So I'm going to use my micropipetter to remove the supernatant. And how I do that is I just put a tip on my micropipetter, I open up my tube, and then I draw off all of the liquid. So I'm just discarding my liquid in our waste disposal container. So now, if you look at my tube, you can see that we just have a pellet of cells. So I'm going to do that for all of my samples, and then you'll tune in again. So we have now removed the supernatant from all of our tubes, so we're just left with a pellet of cells. So what we're going to do is resuspend our pellet in 100 microliters of solution 1. Solution 1 is going to keep our cells intact. So I'm just going to pipette up 100 microliters. And then I'm going to add it to my tube and then I resuspend my cells. So you can resuspend your cells by pipetting up and down, like so. And you'll notice that when the cells are resuspended in the solution, you're going to have a very small volume of a very cloudy solution. So it'll look like this. And I will do this for all of my samples. So the next step of our procedure is to add 200 microliters of solution 2 to our cells. So solution 2 is going to lyse our cells. So our cells are going to break open. So what we do is we'll take 200 microliters of solution 2. It looks like that. And then we're going to add it to our cells. Once we've added solution 2 to our cells, we're going to invert our tube a few times, like 5 or 6 times, to help mix our lysis buffer in with our cells. And as our cells lyse, our solution is going to become very viscous. It's kind of hard to see that right now, but when we open up our tube to add solution 3, we'll see that our cells become very viscous. So we have now added solution 2 to our sample. We've let it sit for a little bit, and if we tilt our tube, we notice that our solution is much more viscous than it was before. So now what we're going to do is add solution 3. Solution 3 is essentially going to precipitate out everything we don't want in our solution. So we're going to add 150 microliters of solution 3. We're going to add it right to our tube, and then we're going to invert about 5 or 6 times to mix. And when we do that, you'll notice that we start getting separate layers. You'll see the clear layer on the bottom and then the kind of whitish fluffy layer on top. The white fluffy stuff is the cell debris that we're going to be removing from our cells, or I'm sorry, from our DNA. So we're going to let this sit while I am finishing up the rest of my samples, and then we're going to be centrifuging. So I'm done adding solution 3 to all of our samples. Our samples look like this. And now we are going to centrifuge for 10 minutes. So I'm going to take all 6 of my samples. I'm going to balance them in the microcentrifuge the way I did last time. And then we will spin for the 10 minutes. So all of my samples are balanced. Put the lid on. I've already set my centrifuge to 10 minutes. We're going to leave the same speed, 12,000 RPM, and we can hit start. Okay, so we have centrifuged our samples for 10 minutes. So now if you look at them, you will see clear supernatant. The supernatant contains our plasmid DNA, and then you'll see the white pellet. The white pellet is going to contain our cell debris. So that's going to contain things like our cell wall and the genomic DNA, the chromosomal DNA that we do not want to keep. All right, so now what we're going to do is transfer the supernatant, which contains our plasmid DNA, to a new microfuge tube. I'm going to do that with a pipette. So I will very carefully pull off the supernatant, leaving the pellet behind, like so. And then the supernatant gets transferred to a new tube. So now we have just the supernatant in our tube. The next thing that we're going to do is add our isopropanol. So we're going to add 600 microliters of isopropanol to our tube. Our isopropanol is chilled. I've had it on ice. And the isopropanol is going to precipitate our plasmid DNA. It will also precipitate any RNA that might be present. So we add our isopropanol to our tube. We are going to invert to mix. And then our plasmid DNA will start to precipitate. We're going to put our samples on ice for 10 minutes. So our samples have now been on ice for 10 minutes, so we're going to centrifuge for an additional 10 minutes. This is going to precipitate out any nucleic acids that are present in our solution. So this can be our plasmid DNA, and it can also be RNA. We did not add any RNase enzyme to our samples So we will have some RNA in our tubes. We will see this RNA as well as our plasmid DNA when we run our gel electrophoresis next time. All right, so our samples are done spitting. So if we look at our samples, if we look very closely, we can see a small pellet of DNA or RNA at the bottom of our tube. We'll try to get a good picture of it so that you can see what it looks like. But this is what your sample looks like. So what we're going to do next is remove the supernatant. This contains the isopropanol, and then we're going to be left with our pellet that contains our plasmid DNA. Our plasmid DNA will then be dried for a few minutes, and then we're going to resuspend our pellet in water. So we're not going to remove our supernatants, so I'm just going to use a pipette to do that. So we have about 1.2 milliliters of liquid in here. So we just remove it, and then we are left with a pellet at the bottom. So if you look at the tube now, you might be able to see it a little bit better. You can see the pellet that contains our plasmid DNA. We have now let our samples dry. If you look at them, you can see a nice pellet of DNA at the bottom of the tube. So what we're going to do now is resuspend our pellet in water. So I'm going to do 10 microliters of water, and what I do is you just put the water into the tube, and then you very gently pipette over the pellet to resuspend it. So when you have resuspended your plasmid, you'll have a solution that looks like that, and you won't see a pellet of the plasmid DNA.